Good morning, all, and thank you to Saga for inviting me to do my talk. And thank you to SRK Exploration for giving me the time to do the talk. Um, I'm going to excuse myself already from the start. I've got a cold, and so if I have a coughing fit, please excuse me. Um, so that's the first excuse. And the second excuse is I'm just an exploration geologist. I'm not a geophysicist, and the stuff that the very fancy geophysicists have done have really helped me, but I depend on them a lot to help me with the project. Um, so before I go into I don't know if I can go back. You should. There we go. So I'm going to discuss at some stage how TEM, the time domain electromagnetics, helped us with a project, a greenfield project. But before then, I'm going to discuss why why we should care. And the main reason for that is really the green revolution. So everybody talks about it, but we are really exposed to it as exploration because we basically, if it can't be grown, it has to be mined. And we are the ones that are put there to try and find things. And it's quite tough. And also when budgets are cut, we're the first guys to be sent off. So we watch the markets and we follow everything that's going on because markets are really fickle. And by that, the area where money is spent is quite fickle. So that's how we plan our work. So essentially, the reason why we were interested in graphite over here is that although there's a prediction, and that's also almost contentious because they say that it's not going to be as high as this, but it really depends on who you talk to and forecasts. But in any case, essentially, with lithium being as high as it is, they predict that it needs to increase by 965%. But I don't know if you can see there, it's only 400 kilotons. Whereas with graphite, here, it's going to increase by 4,600 kilotons. So by magnitude, it's 10 times more than the lithium. So it's often the unsung hero that people forget about, and everybody's on and very excited about lithium, but graphite's its little unforgotten cousin that's not quite as glamorous, but I like it, and that's really the discussion moving forward. So just a little bit about battery chemistry, um, because not I can't talk for too long on rocks because I like rocks, but most other people don't. So the reason, and really this really huge demand, is that in every single battery chemistry that they're looking at, and it's a nice little picture, but the batteries don't generally look like this. But in any case, 95% of graphite is needed in the anodes. So you can change up your cathodes for a whole bunch of different commodities, but what's really important is this need for graphite. So along with needing to know a lot about all sorts of things as explorationists, we always get asked, but can't synthetics be substituted for natural? So, should we even continue with this conversation because we can just go straight to synthetics and we can skip on it. So again, following the markets because we need to. Essentially what started happening was China was dominating the market and Japan and specifically Mitsubishi started doing research into the different percentages that they use for synthetic versus natural. So us as the mining industry, what we face with natural, a lot of people will say it's ESG and monetary based, but if you actually start following it, what it's all about is how the battery performs. And what Mitsubishi has picked up is that they really get the best combination is using both synthetic and natural, and that's essentially what's being seen moving forward. So again, why should we care? So originally, the flake graphite supply is coming 80% from China, and a lot, basically, essentially in Eastern Africa, there's 20% coming from Eastern Africa. But where China really dominates more than anything, is all of this material from Eastern Africa gets sent to China, and they completely dominate the spherical market. So I think it was in 2018. Oh, I see here, I've put it. In 2018, the States and Japan recognized graphite as a critical mineral, and it's more so because of the fact, from geopolitical reasons, it's all coming from China. So they needed to diversify a bit and have a little bit of independence. So Australia followed suit in 2019, and Europe was the first in 2017. Okay, and then further for that, not, not just trying to understand the market, graphite's also pretty fickle. So you get different sized flakes within a deposit, and we need to try and understand that. And essentially, this is what's, or the small flake is really driving this. So with this knowledge, the clients come to us and then they say, please find us rocks. So great, we now know that it's an exceptional market. What makes it harder for us as the exploration team is that it's really tough with the exploration process. So here I think BHP also did a similar study. We start off with roughly 500 areas of somewhat interest. Someone many, many years ago walked around, picked up a rock. We don't even know, was it in situ, was it actually in the ground, was it just floating around? We have 500 areas of interest, and eventually working through it, if we're lucky, we get to one. So in order to increase our odds to meet that demand, we try to look for tools because it's a pretty competitive market. And so far, I've been fortunate enough to work with great geophysicists who have really helped and enabled us to move our projects from that 500 to the one. So the project is based up here in Montepuez. I'll just do a little bit about rocks because, again, I know that it's a bit boring for everyone else. But for me, it's based in the Mozambican complex. It's on the eastern side of the origin, and it goes all the way from Madagascar up to the Arabian Shield. So it's a pretty large area, pretty big. And now we need to find some way to put a mine. It's amphibolites, so that's great. That's what we want. And we do know that historically there are companies that have found graphite outcropping. But that's not so easy. After being in this area, essentially most of the deposits are 70 meters. The weathering has been 70 meters. So a lot of the stuff that we're looking for is underground. It's really hard. And essentially, the company that I was working for is this red, they had the red license holding over here. And I looked at it and it was 700 square kilometers. It's pretty big. And essentially I did, I've actually got my notes here. So I put that into rugby fields, and that works out as 70 billion rugby fields. And if we're lucky, we're going to find three little rugby fields dotted all over these little places, like one up there, one. So how on earth, underground, do I find, or exploration geologists for the market, how do we find this? So, and also, not only that, pretty much anybody who's in the industry knows that capital is a struggle. And Ernst & Young recently looked at the mining business risks. They publish this every year. And last year, capital was one of the most difficult things to find. So it's great that, well, we should be trying to keep people alive and using geophysics to keep people alive. But in my sort of field, we're competing for capital. We don't have a lot of capital, and we need to be innovative and find a good way to use fancy technology that can tell us what's happening underground so that we can move forward with the project. So how we started with that is, again, luckily, we knew some great geophysicists, and we asked them to please help us. And essentially what we decided was we should walk EM34 lines. That's really intensive, it's really heavy, it's really unpleasant. And what I didn't say, this area from here to there, that stretches over 500 kilometers as the crow flies. So from here to Durban, that's the area of interest that we're looking at. What we did know is that people previously had published these areas that were outcropping as graphite. So we knew the trend, and essentially we wanted to walk perpendicular to the way that the rocks were trending to try and pick up some form of thank you, some form of mineralization. So yeah, there we did, and we were actually really fortunate that we did. We got a kick. Again, possibly this means a lot more to a geophysicist than it does to me, but all I wanted was anomalous material which they could find for me, and we were then able to validate these areas of interest. So essentially, there were 5 lines that we walked, and then we used RC drilling, which is pretty, it's destructive. And what I was trying to show earlier was that flake size matters. So doing a destructive method will automatically turn your flakes to the smaller sizes, which matters again for our investors because we have to keep those guys happy. But in any case, so while we had finer material, or we were able to find finer flakes, we were able to prove a TGC, a total graphitic carbon amount of 17%. So the owners of the license were able to go to market and essentially raise money to say, look, we've got this material, give us money and we can find more fancy graphites to feed that market that wants it. And at which point, again, our great geophysicists helped us and gave us a bit of an indication because, again, remember, we've got, what was I said? 70 billion rugby fields to find 3, and in a huge space. So we used TEM. We then were able, so eventually they flew 4,000 line kilometers, and we got a whole bunch of really nice geophysics because we worked with really great geophysicists, and they were able to give us a great output on what we were looking at. And then the geophysicists had to be brave enough to help us and give us 9 anomalies that they ranked as the biggest and what they felt was the best. So they provided us with these 9 ranks, and we went to go and check them out at these different locations. And essentially, what we were looking at, so we drilled them, and we were able to then work out from the analysis what the max TGC was, what our average was, and what our depths went to, because it's a bulk commodity, so it doesn't help. We want volumes. So essentially, from those this huge area of 70 billion rugby fields, we were able to rank now 9 areas that we could follow up with our limited capital. And essentially, we were fortunate enough that we were able to then go into drilling, which we did RC, to just as a quick, inexpensive technique, just to validate is the mineralization there. We were then able to, or what we did, again, because money is an issue, we went and twinned these holes with diamond drilling, and we were then able to go through metallurgical test work to understand what the bigger flakes were. And eventually what we started to realize, what this area, this Kaula mineral resource, was the best. And here I've actually put it where you get your jumbo flakes is at 2,000 or 1,500 versus your fines at 450. So it really has a huge influence on it. But the only reason that we could then get this information for the company to go to market was it was done through this target testing or this refinement of our work through geophysics. So eventually we drilled it out. This is generally more for our geologists. We were working with a whole bunch of creepy crawlies, pretty rocks from my perspective. And eventually there was a 20 million or 22 million ton at an average grade of 13%. And the ironic part was this was a listed company on the Australian Stock Exchange, and it was then bought over by a Chinese company. So really, that is the project summary. But essentially, using a lot of really nice geophysics, we were able to find a resource, and it was successful.
Thanks, Sara. I did enjoy your reference to the wonderful geophysicist. So, I mean, it was SkyTem. I saw, thank you, who we heard from yesterday from Pierre. Any questions from the audience? Yeah. Did any of those spiders crawl anywhere near you? Okay.
The spiders were often under our pole. So we had challenges.
Oh, wonderful. My other question, oh, sorry. Okay, please go ahead.
I've got a question. So it was a topic of discussion yesterday. How did you grow faith in geophysics with whoever was paying the bills? How did you go to take that step?
Well, so again, like I said, we had no outcrop. And once we actually drilled, it was only 70 meters lower. Where we were lucky is geophysics has got a great name with graphite. And so it's built up a big reputation. But I think I maybe should have made a slide trying to find a deposit. I think exploration geologists are really exposed to this a lot. Trying to make success from that 500 projects to one is tough. And so we need to find innovative, cheaper, cost-effective ways. So even though it is expensive, if people can't afford that, then they shouldn't go into mining, because actually our exploration is the cheapest part. It's just the riskiest.
My question was, you wanted to mine, sorry, was on the board. You had the anomaly continues down, but then you don't see it. So are you guys going to buy the next mine place over? Okay.
So should definitely use that link that's on the stock exchange.
Okay.
Figure out how they want to move forward.
Okay, cool. Okay, thank you.